I actually had to like drive slow. You guys got nothing. But it's only 31 degrees out. I hate winter so much, it's so cool. Okay. Find the range of a function. So we're given the function h of x equals 3 minus 2x. If the domain is, and it's given us 4 numbers. So we just remind ourselves, what the heck does this mean? Range just means find the output. If the domain is this, that just means it's giving us the x's. Find your output, so in this case, find my h of x. So basically, really, all you have to do is plug 4 numbers in and then just get 4 answers. So it's just kind of a fancy way. So we're gonna do h of -5, we're gonna do h of -1, we're gonna do h of 0, and we're going to do h of 3. So you plug each of them in individually, you find their answers. What is this? 3 minus 2 times -5. There's a double negative, so I'm actually gonna add those, so that would give me what, 13. 3 minus 2 times -1. That would give me 5. 3 minus 2 times 0 would just give me 3. And then 3 minus 2 times 3, it's 3 minus 6, that's -3, right? And then we said yesterday, like we kind of write the range in the same way the domain was given. So you kind of like list it out. Once again, you can just do regular parentheses or brackets. So it would be 13, 5, 3, -3. And there you go. So I just want to introduce one thing, just while we're kind of writing a few things down, and we'll finish up that work from yesterday. Same type of problem, I'm just going to switch 2 words. It's going to make it a very, very different. What if I said, and this one I said find the range. What if I said find the domain? Ooh, how exciting. Of a function, I'm going to say f of x equals 3x plus 6 if the range is -12, 0, 3, and 15. So just by me switching 2 words, the domain and the range, it's going to make it a very different problem. So you have to be really careful about how things are worded, and knowing what the words mean, and fun stuff like that. So find the domain means find the x's. I don't know what x is. If we know the range, which means I know the output. So please don't just say, oh, I'm gonna plug those in and just like throw in the x's. I don't know the x's, that's what it's asking me, I don't know the domain. So if I don't know the domain, if I don't know the x's, but I have the outputs, that means when I'm thinking about this function, I know this side. So when I say my range is -12, that means that -12 equals 3x plus 6. When I say 0, 0 equals 3x plus 6. When I say 3, and when I say 15, that means I know my outputs, I know my range, but I'm trying to figure out what did I plug in to get those. So in these, you have to do a little bit of solving. They're just quick little two-step equations, they shouldn't be too bad. If I subtract 6, that would give me -18 equals 3x. So my first answer is x equals -6. Here, same thing, if I subtract 6, that gives me -6 equals 3x. So x would equal -2. If I subtract 6, that gives me -3 equals 3x. So x is going to equal -1. And if I subtract that awkward, I'll get kind of 6. That gives me what? 9 equals 3x. So x would equal 3. So in this case, I found the domain, and it is -6, -2, -1, and 3. So we'll practice more. I think there's another example on that little thing we were working on yesterday. But just so we're starting to get used to the vocab in this chapter, things like domain and range, and we're gonna talk about some other stuff today as well. But just by switching those two words, it makes it a very different problem. So please be careful that you are reading and maybe making even little notes to yourself. Domain is my X. Do I know my X's or am I trying to find my X's? Because it does make a difference. Are there any questions with that warm up or with that extra problem we just did? Okay, so if you find yesterday's sheet, I know we didn't finish it, I just wanted to look at it. I hate like I always do that and then I just forget to finish it. There's probably information that we need on there, so I'm gonna find mine. Maybe. Here. Sorry, I'm just getting mine up. Projecting it. So we had already done the front. Were there any other questions from yesterday on function notation and stuff that we were doing? Let's get it. Like the actual plugging in isn't bad. We've done that a million times. It's just getting used to the notation and what it means. Okay. Boop, 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 boop. So we were kind of chugging along yesterday. I think we were working on some of these. We don't have to do all of them. So the main goal, as you know, these were given domain. So these are each of your X's. You were plugging them in. So you guys were kind of finishing up with a few of those. I did want to do these last few problems though, because it's good. What we see may pop up later, and it's always good to see more examples. So number 5. We just read through it. Okay, a 10th grade class is selling granola bars. Ooh, delicious, for a fundraiser. They earn 75 cents for each bar that they sell. They have ordered 300 granola bars for the sale, and they have a nice little, we call that a function rule. It's like a little equation, but it's a function. And the function P of B, so that's how we say that, equals 0.75B. Okay, so P represents profit, and B represents bars they sell. Find a reasonable domain and range for the function. Ooh, this is so exciting. So let's think about what domain means. Domain, I'm just gonna make little notes to myself, means my input. Right? So think about this actual function. P of B equals 0.75B. My input is B in this case. So my input in this case is B, and B represents number of bars that they sell. So what's a reasonable domain? Am I ever gonna sell a negative amount of bars?
No.
No. Can I sell 0 bars? Yeah. I could sell 1, 2, 3, 4. What can I sell up to? 300, right? Because that's all they ordered. So I can't sell 301. So basically, for them, the domain, so basically the values that would make sense for this problem, they could sell anywhere from 0 to 300. So negatives don't make sense, about 300 doesn't make sense. So we would just write that as B is greater than or equal to 0 and less than or equal to 300. And that would be the domain of this function. Because if I just throw a function at you and you know nothing about it, you could really plug anything you wanted into it. But this one, since there's context, we want to think what makes sense. It only makes sense that they would be between 0 and 300 because you can't sell negative amounts and you can't sell more than you have. So that's just kind of thinking logically. It also asks what's a reasonable, if I could talk, range. So the range is my output. In this case, it's being represented by P of B, and it means my profit. Now you kind of get your profit or your range from your domain, right? Because if I sell 0 bars, how much am I gonna profit?
Minus 300?
Well, yeah, I guess you, yeah, that's that one. Well, profit, you don't need to take into account how much you spend. It's how much you're making. Okay.
Zero.
So I could make $0. That would be a pretty terrible fundraiser, but I could start at 0. And what is the most money that I could make off of this fundraiser? I don't know. I'm gonna grab my calculator, 17 million. Well, the most I can sell is 300, and they're selling for 75 cents each. Nope, I've got 30, so that's not gonna help me, Mr. Sherman. The most is 225. So I took the most that I could sell, and I multiplied it by how much profit I'm making, which is 75 cents. And I already forget what it was. 225, okay. 225. So we could say P of B, my profit, is either greater than or equal to 0 or less than or equal to 225. I'm gonna put little dollar signs because we're talking about some months here. So those were just kind of thinking about what values make sense for that function and that situation. So it makes sense that they can sell between 0 and 300 bars, and then off of that, their profit would be between 0 and 225. Okay, so we talk about domain and range quite a bit, and we try to relate it back to what we're doing. So number 6, the function, so it gives us a function again, t of x equals 150x, represents the number of words, that's t of x, you can speak in x minutes. That's exciting. How many words can you speak in 20 minutes? So here's my question. It's always good. It's kind of labeled for you, but it's easy to kind of like glaze over things and go, no. When I say 20 minutes, am I gonna plug that in for x? Is that my input or is it my output?
Your input.
Yeah. Wait. Yeah, because, sorry, even I got confused on that one. 20 minutes, but it says, X is minutes, right? X minutes.
Oh.
I know, the way it was worded was a little weird. So even if you wanna I feel like sometimes, once again, the way those things are worded are a little funky. So if you wanna like relabel X as minutes and then, T of X is number of words, sometimes that helps me just organize, like where are things going? Sometimes I like to just reclassify things. So if I say how many words can you speak in 20 minutes, I'm gonna plug x is 20. So it would be t of 20 equals 150 times 20. Okay, so the actual math isn't bad. I'm just gonna throw that in the calculator, I have no clue what that is. But 150 times 20. No, 150 times 20. Oh, I could have done that, that was really fast then. Okay. So that's that. Once again, labeling is always useful, especially when you have different situations. And then the second part says, how many minutes, so I'm trying to find X now, does it take for you to speak 1,275 words? So that means my T of X is equal to 1,275. And that's gonna equal 150X, and I need to find what X is. Okay, not the hardest problem, but sometimes it can just get a little tricky with where things are going. So always trying to maybe relabel, or doing little things like that. X comes out to 8.5 minutes. Once again, I already forgot what X was, and I had to look back at what I had written to remind myself it was minutes. So our main goal today is really just to get used to those functions written in that notation. What goes where, all that fun stuff. Okay. So I think we just have like 2 Randaruni problems here. Let's see what we got. If f of x equals x squared minus 15, and f of a equals, this one looks fun, equals 49, what is the value of a? Okay, so let's just think about it. So it's telling me a function, delightful. It's telling me that an input when I plugged it, an output when I plugged in A was 49, and I need to find A. So don't get freaked out because they're changing the variable. It's the same thing as saying what's X, it's the same thing. They just change the variable to make it fancy. What they're telling you right here is this is an output. So when I'm thinking about this function, I can change this to A if you really want. Here, let's change it to A to make it all the same. Oops, I changed it to A in one part. Okay. But if I change that to A now, maybe it will make a little more sense. F of A is 49, so this is 49. So maybe sometimes just rewriting, I feel like if I had just thrown that at you, that would have confused some people. But you can change the variable, go for it. I'm gonna add 15 to both sides because I don't know what my answer is right now. A squared is going to equal, no,
64.
64. Where was I getting that from? Thank you. That was a struggle on my part. And then I take the square root, and A is gonna equal 8. Okay, so it's kind of a different way of just asking, okay? Sometimes just changing that little letter might have freaked you out, but that's a problem we've done before. So going from there. And then number 8 was kind of like that problem we did at the beginning. So find the domain. So I'm finding the x's. Find the x's. Find the inputs. Find the million different words we have for it. F of x given that range. So that means these are my outputs. These are my f of x's. Given f of x's. So I'll set the first one up, but I'm gonna have you guys finish this one. What that means is I'm given this side. So my first thing, I would do negative 5.5 equals 1/2 x minus 3. You would do that for your other outputs, and then can you please solve and tell me what would that domain be? So I'll give you a second. I want to take attendance. I'm losing my pencil. I just did. We got page handwrite. Okay, so we got 15 minutes. We can kind of start the next thing, but we won't rush ourselves. What's up? Yeah, go. I'm just gonna kind of set mine up and solve mine too, and then we can compare the episodes. 7 is here. I'm ready to my calculator. I'm too lazy to do this in my head. Alright, so what do we get? I find them in total? So once again, we have 4 numbers in the range, which would correspond to 4 numbers in the domain. So once I find them, I found my domain was -5, -1, 2, and 10. What a beauty. So take a second, just check that you got that. It's really just reminding yourself what goes where. So once again, that's not necessarily the hardest math, just solving the 2-step equation. But if you put it in the wrong spot, it would definitely be kind of a mess there, so. Just as a heads up. All right, so I did want to finish those from yesterday, so thank you for bearing with me there. Because those are things that'll kind of pop up. We'll see a lot more with function rules, aka just equations written in function notation, plugging into things, domain range, so stuff we talked about, but it's always good to practice with as well. So any questions with that? So once again, sometimes I'll give you a worksheet, sometimes I kind of do notes. I do suggest you keep these because we will refer back to that information later, whether it's you're taking an assessment at home and it's nice to have your notes. Or, we have a nice little vacation, but after vacation, I might say, hey guys, remember how to do this? And if your answer is, oh crap, I don't, then you have something to look back at. And so put that wherever. I am going to look at the other worksheet that you grabbed today. We're just going to do something quick on it because we only have about 10 minutes left. And then the rest of it we can kind of leave for next week. I was going to rush, but what's the point? We got nothing but time, guys,
Mr.
right?
Chairman,
Yeah, what's up?
will you go over one of them? Because I keep getting the same answer that I have.
Which one? Maybe I did it wrong.
So -5.5, and then you have the +3, so that's -2.5.
And then divide it by.
Divided by half, I get -1.25.
Yeah, that's what I got too.
Hold on, -5.5 plus 3. Divided by a
I
half.
got the normal answer.
It's -5. You're dividing by a half.
Oh, you have to multiply.
You have to, wait, no, I don't know what you're doing.
I still multiplied and got
Okay.
that answer too.
So you have to divide by half because the x is next to it.
Yeah, but when you divide by half,
You multiply by
you multiply by
2.
2 over 1.
Okay.
Or your calculator, are you doing it in your head or?
No, I did it with the calculator. I just inputted it as 5.5 divided by half. Or, 2.5 divided by 2.
So when you are putting in a half, are you putting in 0.5 or are you putting in like the fraction of half?
I just put divide by 2.
Wait, why are you dividing by 2? You're dividing by a half.
Well, yeah, that's probably.
That's why.
Yeah.
So when you do it, divide by 0.5 and then it should make it correct. But technically you're multiplying by 2 because you multiply by the reciprocal, so it's a little funky. But yeah, that's something that pops up now and then. All right, so can you take that other, or just have that other worksheet there, this one that requires you to find it. So give me a second in my 8,000 things that I have saved. Yes.
Can I go to the bathroom when he comes back?
Yes, we can. Number 4, I think it's called 4-5. Sorry, I have way too many. Give me a sec. Probably don't need worksheets from 2012 anymore. I can probably, this one. Yeah. Is this what it looks like?
Yeah.
Yes. Okay. I feel like that's not what it looks like on the back though.
But it doesn't, never mind.
No, yeah, okay. Hold on. That's okay. This is one. Oh, because I picked the wrong one. All right, update it as now that's what it looks like. And yes, okay. Perfect. So we might just do this first part. That's okay. And then whenever we don't get to, we'll finish next week together. But you will have some practice. Once again, there is going to be like a little edge elastic kind of mini thing on Friday. I'm just talking about, is this a function? And can you kind of plug into function notation? There might be a little few domain range things on there, so if you forget, or if you're like, oh man, is this one where I like flip it, just look at that worksheet. That is your resource for you. And so go from there. So you've probably heard of independent and dependent before, but it's always good to kind of re-go over this stuff. So our independent variable. Right, let me just write that, is that a long word? It's just my x. We also call it our input. Sure, there's other words I can use for it, but that's what we've been referring to it so far, the x or the input. We can also call it our independent variable. And our dependent variable is our output. I'm gonna call it f of x. You can say output. Sometimes we still, just like out of habit, think of it as our y. So it's just fancy new words for things we kind of already know about. But we want to make sure as we're doing a problem, we know which variable is which, because that's going to help us write our function rules, aka our equations in a few minutes. It's going to help us graph, because when you graph, your x is your independent variable, and your y is your dependent variable, or your dependent axis, I should say. So it is something we kind of take a few minutes and just make sure that we're semi-understanding. I'm going to go from there. So given the two variables, state which variable is independent and write them in a sentence using the words is a function of. So what I usually do is kind of start off with a little saying that one of them depends on the other. I still use this in my head to this day because sometimes I just go in and I don't know which is which. So one of the variables is going to depend on the other one. So the other one can change and that affects whatever the other variable is. So when I say, I'm going to say two statements, tell me which one you think makes sense. And sometimes you say them and you're like, they sound the same, I don't know. So we'll just do our best. Does the cost depend on the number of toppings? Or does the number of toppings depend on the cost?
Number of toppings depends on cost.
Other way around.
It's the other way, I know, they both sound right. If you ever get confused, think about how you would graph it. So if you think about, if I graphed it, I would have to put toppings here because I need to know how many toppings I have in order to know the cost, right? I would never know the cost before I didn't, like, if I just said, what's the cost? You'd be like, well, how many toppings are there? Because the cost depends on how many toppings are there. I know it sounds weird now, we'll get used to it, but don't. So the cost is going to depend on the number of toppings. So once again, think about the one, like if I didn't know what the other variable was, would it make sense? If I didn't know what the number of toppings was, I wouldn't know the cost. But I could know the number of toppings without knowing the cost. Same deal. So the cost depends on the number of toppings. So since this depends on this is dependent. And this is independent. So if I use that little saying, just make sure you know the order. So the cost depends on toppings. That means this is dependent, this is independent. I don't really care how you label it, just make sure you do label it. It says use the word is a function of, you don't necessarily have to do that. I'll just do it for this first one. We would just say cost is a function of number of toppings. You don't necessarily need to write that out, but
Could you just write C of X?
yeah, that's fine.
Yeah.
Okay, so it's just something you need to get rid of, get used to. I know sometimes it kind of sounds right both ways, so you have to be careful. But just think to yourself, would I know the cost if I didn't know how many toppings there were? No, I need to know that toppings, so the cost depends on how many toppings are. So number of scoops of ice cream and calories consumed. So think about which one is independent. Which one could you just know and the other one doesn't really matter?
The number of calories consumed depends on the number of scoops.
Yeah, because in order to know how many calories you consumed, you have to know how many scoops you had. if I had said the scoops depends on the calories, you would say, I know how many calories I have, and in fact, that doesn't make sense. So the calories depends on scoops. So we would say scoops is, once again, calories depends on, so calories is dependent. This is independent. You can write it as thing if you want. Ooh, I like this one. The number of hours you study for a test and your test score. I feel like this is a semi-relatable one. Hopefully the more you study, the higher the grade you get. So would we say that hours depends on my test score, or my test score depends on the hours I studied?
I would say test score depends on hours.
Yeah, so obviously I don't know what the score is yet. So my score depends on how much I studied. Once again, the more I study, hopefully the better my grade is. The less I study, it might be a little lower. So the amount of time I study is affecting my score. So when it has an effect on the other variable, that means it's dependent. So the score depends on cost to fill your gas tank and number of gallons of gas in your tank. Sorry, that's. So does the cost depend on how many gallons I have? Or does the gallons I have depend on the cost? Adrian.
Cost depends on number of gallons.
Beautiful. Most of the time when we're talking about cost is the dependent, because it depends, how many gallons, how many toppings, how much of whatever you're doing you're buying. So most of the time, cost is always going to be your dependent. So just as a hint, cost is dependent. Okay. So what we want to get used to doing, and I'm going to go back and kind of do it for each of these, is we want to get used to now relating that to function notation. So we have all these variables. How can we write them with function notation? So once you know you're independent, dependent, you're going to go back. You're independent, you just pick a variable. So let's say we do this one. And I said we have cost of pizza and number of toppings. I'm going to say number of toppings since it's my independent is going to be represented with T. Toppings, T, you can choose X if you want. But then since the cost depends on the toppings, we need to write this in function notation. The cost depends on the toppings. So we want to get used to relating that to function notation. So your toppings is independent, you can just have T, but your cost depends on toppings, so we write it as C of T. So this one, oh God, I got out of time. I'll just do this one now, we done. Calories consumed, oh wait, excuse me, I want independent as number of scoops. I'm gonna label it as S. And then the calories depend on my scoops. And then I'm gonna be done during that time. So I knew we were gonna finish, that's okay, I didn't wanna rush and try to kill us here. So if you need help as the week goes on, just let me know. But other than that, have a nice end of the week. I will see you virtually, but when I say see you, I'll see your dot with your little face. So other than that, have a nice weekend.